I'm going to teach you very important lesson to you about equation. Under this, we discuss constructing simultaneous equations with rational coefficients and solve simultaneous equations with rational coefficients and how to solve quadratic equations by means of factoring, completing the square and using formula. Okay. In earlier ways, you already discussed these things about simple linear equations, meaning equations having only one algebraic term. And also you discuss about the simultaneous equations when you are in grade 10 and 9, equations having two variables, and also quadratic equations like this: x squared plus bx plus c equals 0 when a unequal 0. Okay, right. So as first, I would like to explain to you simple simultaneous equation, right? This is the first example is given x plus 2y equals 10 and 2x minus 5y is equals 2. So I will explain how to solve this equation, right? As a first step, first you must name these two equations. You can name it as equation 1, equation 2, and then you have to check the equations. First you have to check the coefficient of the terms, algebraic terms. When consider x, the coefficient of x in the first equation is 1 and in the second equation is 2, is different. And also when check the coefficient of y in first equation is plus 2 and second equation is minus 5 is also different. So we have to make, as a first step, first we have to make equal coefficient. To remove a term from these two, we have to make equal coefficient. And so to make equal coefficient, here I multiply this first equation by 2. And you can see when multiply the first equation by 2, each term of the equation should multiply by 2. Then 2x, when multiply x by 2 is 2x, and when multiply 2y by 2 is 4y, and 2 by 10 is 20. Then you can name it as a third equation. Okay. And the next one, when consider it with the second equation, 2x minus 5y equals 2, then this is the second equation, then you can see the coefficient of x is same. And also the sign is same, the sign of the coefficient are same. Then you have to select suitable operation. Yeah? When subtract the second equation from the third equation, I will explain how to select this operation here later. Right? Then we subtract, and normally you can subtract. When subtract equation 2 from equation 3, left hand side of the second equation you must subtract from the left hand side of the third equation, right? You can use bracket here, 2x plus 4y minus 2x minus 5y and is equals, difference of the right hand side is 20 minus 2, right? And then you can remove the brackets, 2x plus 4y, when remove the brackets here, right? You should multiply each term in the bracket by this negative sign, negative, positive, negative, minus 2x, again minus, minus is converted to plus, plus 5y is equals 80. And then you can see here 2x is positive, here is negative. Then you can cut and get rid, and remaining 4y and 5y remain. Then sum of them is equals to 9y, and right hand side value is 80. Then 9y equals 80. And 9y equals 18, then you can divide both sides by 9 and you can make y as a subject of this. Now the value of y is equal 18 over 9 is equals 2. And as the next step, you have to substitute, right? Because here we already calculate the value of y, also we have to calculate the value of x, right? Because we have two variables, right? So to calculate the value of x, you can substitute this value, the value of y, in first equation or equation 2, right? You can select suitable equation for that. Here I select the first equation for that. Then x plus 2y equals 10. Then when substitute, then you can see here, right? For y we substitute 2. 2y mean to multiply by y. So 2 times 2, x plus 4 is equals 10. When make x as a subject here, the value of x is equals 6. Then subtract 4 is equals 6. Okay, I think you can understand this first example. Right, we already discussed this type of equations when you are in grade 10. Then is the way we select this operation. If the sign of the terms having equal coefficient are equal, then you can subtract the equation. Can you understand? Here, if sign is same, here plus, then this one is also plus, then you can select to move 2x from these two, you can subtract the equation. If the sign here minus minus is also same, if x is 2x is minus and here is minus, to move that term, again you can select the same operation, subtraction. And if sign of the terms having equal coefficient are different, then add the equation. Mean if one is positive, the other one is negative, the terms having equal coefficient, then you can add and you can remove that term. That's the method you follow. Right. So we can move to the next example. Again, I will explain another example for you. The difference is here. The variable, the coefficient of m is different, and also the coefficient of n is also different. Normally, as a first step, first you must name the two equations. You can take it as equation 1 and equation 2, and then we have to make equal coefficients. To make equal coefficient, here I multiply the first equation by 3. And you can see what happened here. When multiplied by 3, 2m by 3 is 6m, then again by 3, 3, 9, and 13 by 3 is 39. Similarly, if we can multiply the second equation also by 2, then 2, 6m, then 5 by 2 is 10n, and 21 by 2 is 42. You can name them as equation 3 and equation 4. And then you can see when multiplying, the coefficient of m now equal. And also they are signed here in the first one is positive and second one is positive. Now I think you understand what is the operation we must select to move this term. Okay, if sign is same, we have to subtract the equation. If you like, you can subtract third equation from the fourth equation, or you can subtract fourth one from the third equation. Right here, we subtract third one from the fourth one. Then 6m plus 10n. Then subtract the right hand side, left hand side, 6m plus 9n. Here 42 minus 39, because here we subtract third one from the fourth one. Right? When remove the brackets, you can see how to change the sign of the terms. Here 6m plus 10n minus 6m plus minus again minus 9n, 42 minus 39, the value is equals 3. And here you can say 6m, then this one is positive and here is negative, is cut and remove. Then 9, 10n minus 9n, the remaining value is n. Now n is the subject, is already the subject here, then the value of n is equals 3. Okay, normally as a next step, you must substitute this value. Right, you can select one equation out of the two equations here. Right, here I select first equation for that. Then 2a plus 3a is equals 13. Then substitute 3 for n. Then you can see 2n and 3 times 3. Then we multiply by 3. 3 times 3 is equals 13. The value of 2n is equals, then take 339 into right hand side, it's changed to minus 9, and 2m is equals 4, then the value of m is equals 2. Right? To make m as a subject here, you must divide both sides by 2, then value of m is equals 2. Right? And also, you can write the answers, m equals 2 and n is equals 3. Now, I think you have an idea how to solve simultaneous equation having integer coefficients. Right? Okay? Before you move to the next step, I think you can complete, you can check and you can solve these simultaneous equations. Right? Before you move to the next part of the lesson, first, yourself you can solve and check the answers. Right? And we can move to the next part. Next part means what we have to learn in grade 11. we have learned before how to solve pair of simultaneous equations when the unknown terms, you see, right, are integer coefficient, right? Earlier we solved the simultaneous equations, the coefficients in the coefficient of them are integers, right? And here under the grade 11 syllabus we have discussed here. Now we will explore an example here how to solve pair of simultaneous equations when unknown terms have fractions as coefficients, right? For example, right, when consider the simultaneous equations here, the coefficients of the terms you can see are fractions, right? Yeah, the coefficient of A is a fraction, and coefficient A is a fraction here, 1/3, and a B is 1/5, and B again in the second equation is 1/4. Okay, so I will explain how to solve this type of equations. And this is the first example. 1/6a minus 1/5b is equals -2, 1/3 a plus 1/4 b is equals 9. Normally you can name them as equation 1 and equation 2. Right? That is our first step. And I will explain this as a first method. Right? If you like, you can remove the denominators of each term, right, by multiplying each equations by the fractional LCM of the fractional coefficient. Here 6 and 5 are the fractions in the first equation, denominators of the fractions. Then the LCM value 6 and 5, LCM of 6 and 5 is 30. Right? So you can multiply each term of this equation by the LCM value. You can see here, right? First equation multiplied by 30, then what happened here? 30 multiplied by 1/6 and minus again 30 by 1/5 is second term and minus 2 by 30. Then you can see here 6 times 5, 5 times a, 5a remains here, 5 times 6, 6 times b, 6b, 5a minus 6b, then minus 230 is minus 60. You can take it as a third equation. You can see that in this equations there are no fractional coefficients. Similarly, for the second equation, right, to remove the denominators of the fractions, right, you can multiply LCM of 3 and 4 is 12, and you can multiply the second equation by 12, and multiply it by 12. Each term should be multiplied, you should mind it. 12 by 1/3 a, then 12 by 1/4 b, again 12 by 9. 3 times 4, you know how to simplify fraction, multiply fraction by whole number, right? You can simplify it. 4 times a, 4a, and 4, 3, 3b. 9 times 12 is equals 100a. You can take it as a fourth equation, right? Then we have two equations. There's no fractional coefficients, right? We can move to the next part, right? But the problem is here, the coefficient of a is different and coefficient of b is different. So we have to remove a term from these two. We have to make equal coefficient, right? To make equal coefficient here, I multiply the fourth equation, this one, right, by 2. Then what happens? You can see what happened here when multiply the fourth equation by 2. Then first term is changed to 8a, then 3b into 6b, and 100a by 2 is 216. Now you can see the coefficient of b in third equation and fifth equation is same, right? Is 1 in the first equation is minus 6 and second equation is plus 6. Sign is different, right? Then we can remove that term from these two, right? To remove it, you know, if sign is different, we must add the two equations, right? When add them, 5a minus 6b, then plus 8a plus 6b, then also you have to simplify the right hand side, minus 60, 216. When simplifying, you can say then remaining terms here minus 6b plus 6b cancel, 5a and 8a are remaining, 5a, 8a, left hand side is 13a, then right hand side value minus 16, 216, then 156. Then 13a is equals 156. Then to make a as a subject here, you can divide both sides of the equation by 13. when divided by 13, 13a when divided by 13, also you have to divide 156 by 13, then value of a is equals 12, right? And to find we calculate only one variable, the value of one variable. To find the value of the other variable, right? You can select an equation 1, 2, 3, 4, 5. Then there are 5 equations, right? You can select one out of them, but it's better you can select an equation, right, having integer coefficient. So I select the third equation in that. We can substitute the value of a here, 5a, 5 times the value of a is equals 12, then minus 6b equals to minus 60. Then when make minus 6b as a subject, we should move that 60, 5 times 12, 60 into the right hand side of the equation. Minus 6b is equals minus 60, same sign. So you must add the values, numerical values. Then is equals minus 120. So minus 6b is equals minus 120. To make b as a subject, again you can divide both sides by the coefficient of b. Coefficient of b is minus 6. When divide both sides by minus 6, then b obtained as 20. The value of b is equals 20. Okay. Again, I will explain the same problem in another method, because then you can select suitable method for you, right? Here we make a as a subject, right? First you can make a term, you can select an equation and you can make a term of it as a subject. So here a as a subject, we make a as a subject in equation 1. 1 over 6a minus 1 over 5b is equals minus 2 is the equation given, right? So 1 over 6a, to make a as a subject, we should move 1 over 5b from the left to right, then is converts to plus 1 over 5b, right? When simplify it, right, we can multiply each term by 6. When multiply this term by 6, you can see 6 cancel. When multiply this term by 6, 6 times 4 minus 12, and here is 6 over 5b, right? Multiply both sides by 6, you can take it as a third equation, the value of this, and you can substitute it in the second equation, right? Then you can say 1/3 a, 1/4 b is equals 9, that is the third equation. Then you can substitute the value of a here we obtain, right, to the value of a in this equation, right? 1/3 minus 12 plus 6 over 5b plus 1/4 b again is equals 9. You can simplify it. 1/3 by minus 12 equals minus 4, and then this, when simplify this term, you know how to multiply a fraction by fraction, positive, 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 then sign is positive. 3, 2, then 2 over 5b is remains, and plus 1 over 4b. Then again you can simplify it. Here 8 over 20b, 5 20b is the second term, right? When denominators are equal, then 9 4. Then if denominators are same, you know you can simplify their numerators. 8 by 13, 13 over 20, b is equals 13. So when make b as a subject, first you have to move 20 from this side. So you can multiply both sides by 20 and you can move it. And to make b as a subject, again you can divide. You have to divide both sides by 13. Then value of b is equals 20, right? To find the other value, in the value of a, you can substitute it, the value of b in equation 3, or you can select third equation of equation 2, and you can find the value of a. Okay. So I will move to the next example. 3 upon 5a plus 1 over 3b is equals 3. The next one, 1 over 2a minus 1 over 3b is equals 8, right? In this equation, I think you can say the coefficient of a is different, right? Is 3, 5, and in the second equation is 1 over 2, but in the coefficient of b, when you consider the coefficient of b, in the first equation is 1/3, in second equation is also 1/3. right? You can say equal coefficients, right? When name the equations, and as once we can remove the term b from these two because coefficient same, sign is different, then you can add the two equations. Then what happened here? When add them, then the term b is removed, 130, 130 removed. Then you can simplify 3, 5a and 1 over 2a, finding the common denominator. Common denominator is 10, then 11a. Now how to simplify that type of fractions? Then 8, 3, right hand side value is 11. So as once you can make the value of a, right? A is equals 10. Normally you have to substitute the value of a in equation 1 or equation 2, right? And then a is equals, the value of b is equals minus 9. Okay. And another example in this one, the difference is the coefficient of q is a mixed number. Earlier we discussed normal fraction, right? There, but here is a mixed number. When naming equations, right? First equation multiplying by 5. Okay. You will see what happened when multiplied by 5, right? When multiply the first equation, each term of the first equation by 5, normally you can multiply the numerator part because there is no common factors. 5 times 2, 10. 10 over 70. And when multiply the second term by 5 is also same. 5 times 1, 5 over 3 cube. Then 5 times 5 is equals 25. Right? And the second equation, you can convert this mixed value into an improper value. 1 over 2p, improper value of improper fraction of 2 over 3 is 5.3 cube is equals 12. You can take it as both the equation. Then when consider equation 3 and equation 4, then we will see the coefficient of q is same coefficient and sign is different. You know the operation of select the operation here. If sign is same, you can subtract the equation, right? When subtract it, steps are given here. 10 over 7 minus 5.3 cube. Then subtract the left hand side of the fourth equation, 1/3, 1 over 2p minus 5.3 cube is equals 25 minus 12. Then 10 over p, then remain here 5 3 cube remove, and from this minus 1 over 2p is removed, right? Is equals 13. When simplify this part, you obtain 13 over 14p, then is equals 13, and then you can make p as a subject as grade 11 students, right? You know how to make it as a subject, right? Then p is equals 14, right? Then that value you can substitute in equation 1. When substitute it, you can obtain the value of q. The value of q equals minus 1. You can check it, right? You should complete this one. You have to practice, right? You have to write this question again and practice it, right? Practice and try to obtain these values, right? That's the way you have to follow this video, right? Okay. As your homework, right? You can complete this exercise, right? You can pause that video and you can write them in your book and you can do this exercises. And here is given 4 and 2, 3 questions, and then word problems also given, right? Here you have to make according to the given information. You read and try to make the equations, right? Is given shown about information in a pair of simultaneous equations, considering that the number of girls as x and number of boys as y is given, right? Like that, read and make the equations, right? And then solve. You know how to solve that type of equations, right? You can complete them as your homework, and this one is also same, right? First read the question carefully and construct the equations. Variable are also given x and y, right? Then you have to make the equations and solve and answer the given questions, right? This one is also same, right? You can complete them as your homework, right? Because we are staying home, you have more time, so you can solve them as your homework, right? This is the end of video. So I think you have an idea about simultaneous equations now, right? You can complete the other exercises in your textbook as your homework. Thank you.